Solving trig equations with squared functions on an interval. All right, so we are still looking at problems on an interval, so just in that first rotation from 0 to 2 pi of trig equations. And these equations look a little bit different than the ones we did in a previous video. In the previous video, we saw things like 2 sine squared plus 3 sine plus 1 is equal to 0, and we talked about solving those. You had to factor them. And in each of these ones, notice that there was a middle term. There was that like b term right there, which made it into a factorable quadratic. However, on these problems here, there's just the squared term. Now, back in the quadratic video, I kind of talked about this where we split up a x plus 5 squared equals 4. We split this up down here into two different equations because we use the square root rule, where you take a square root, you put in a plus or minus to account for both the positive answer and negative answer. All right, so we're going to use that same idea here with sine squared x minus 3 equal to 0, 4 sine squared x minus 3 equal to 0. We are adding that 3 to both sides. So we have 4 sine squared x is equal to 3. Dividing both sides by 4, sine squared x is equal to 3 over 4. Again, when you go from x squared equals a number, or whatever, sine squared in this case, but x squared equals a number, to taking that square root, because that square root kind of cancels out the square, to taking that square root, remember to do a plus or minus before that square root, right? So if you have x squared is equal to 25, you have x is equal to positive 5 or negative 5, plus or minus 5, because either of those work in that equation. So over here, taking that square root on both sides to get rid of this square, we have sine x is equal to plus or minus the square root of 3/4. We can distribute that square root on the top and bottom. And this simplifies to plus or minus square root 3 over 2. Now, there are two different ways we can look at this. The first way we can look at it is as a dual equation, right? So what we have at this moment is sine x is equal to plus or minus the square root of 3 over 2. We have the positive version. So that's sine x equal to positive square root 3 over 2. Sine refers to y values. So we're looking on the unit circle for where the y value is square root 3 over 2. Positive y values on the upper part of the circle. Whoop. Square root 3 over 2. Those are our two values here at 2 pi over 3, pi over 3. So those are the two answers for this one. X is equal to pi over 3 and 2 pi over 3. And then the second equation is with this negative sign. So you would have sine x not equal to positive square root of 3, but negative square root 3 over 2. Again, sine is a y value, so we're looking for the negative square root 3 over 2 being the y value. Negative y values on the bottom part of the circle. And negative square root 3 over 2. That's going to be here and here. So 4 pi over 3 and 5 pi over 3. Four pi over 3, 5 pi over 3. And those are our answers. We can write them all out now. X is equal to pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Now, I thought there was a different way you could look at this. You could look at it as splitting this into two separate equations. Or you could look at this as saying, hey, give me all the angles where the absolute value is square root 3 over 2. So any of the angles where the y value is square root 3 over 2, if it's positive, negative, just give me all of them. That's the other way to look at it. Either positive or negative, just find all of them. Here are the positive ones. Here are the negative ones. Either way, you're getting that same answer. It's two different ways of looking at it. All right, so let's go ahead and do one more example here. 3 tangent squared theta minus 1 equals 0. 3 tangent squared theta is equal to 1. Tangent squared theta is equal to 1 over 3. Take the square root on both sides. Don't forget the plus or minus. Plus or minus the square root of 1 over 3. Distribute that square root on the top and the bottom. You get plus or minus 1 divided by square root 3. So we're looking at tangent of theta equals plus or minus 1 divided by square root 3. We know that tangent is y divided by x. We've talked about in a previous video how when you're looking for tangent or cotangent values on the unit circle, because all of our special angles in the interior of the quadrants, all the x and y values are divided by 2. No matter which of these duos you divide, it doesn't matter if you're doing x divided by y or y divided by x, these 2's on the bottom are going to cancel out, so you don't even need to think about them when you're dividing to figure out the tangent values. Let's just say you don't have the tangent values memorized completely. So you can just divide the numerator by the numerator in the other fraction here. So y divided by x, we want it to be 1 divided by square root 3, right? Tangent, again, y over x, I'm going to put that right there. This is square root 3 divided by negative 1. That's negative square root 3. That's not what we're looking for. This guy here, right, we know it's going to be 1, but square root 2 over negative square root 2. That's negative 1. That's not it. This guy here, 1 divided by negative square root 3. Well, there is one of them. We are welcome to do one of two things. We can split it into 2 equations like we did with the previous one, or we could just say, hey, any of them, positive or negative, where the y divided by x value is 1 over square root 3, it is right here, that those are all my answers. Once you have found one of them, because of all the symmetry that the unit circle has, you're in great shape. So I have found one of them. It's at 5 pi over 6. That's the negative one. The other negative one will be directly across the circle over here. This one, 11 pi over 6. But it's going to be all the pi over 6 angles is what it's going to end up being. So the negative ones are in quadrants 2 and 4, and then the positive ones will be the pi over 6 angles in quadrants 1 and 3. Circle those. So all the pi over 6 angles is what it comes out to. So theta is equal to pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And that's that. So not so bad. Just remember to do the plus or minus. That's the key thing. That's the thing that you're probably going to mess up the first time, and then you'll remember and won't make that mistake again. And in the next video, we will finally move out of working on an interval, working on 0 to 2 pi, and start talking about every solution. All right, I'll see you in that video. Bye.